Okay, we are going to talk about binary numbers today and how to convert decimal numbers into binary numbers. So first of all, to understand what binary numbers are, our computers can only understand things that are on or they're off. It's either 1 or it's 0. It's electricity. It has nothing to do with the way we count. We count using our fingers. We count up to 10. Computers only count up to 1. And really what they're looking for is whether something is off or whether something is on, right? So if something is off, computers view that as all zeros. If something is on, computers view that as all ones, right? And the way binary works is in order to create numbers and letters, computers use a variety of zeros and ones. So for example, if something is half on and half off, notice that these lights are on, these lights are off, you count this as a 1, you count this as a 1, you count this as a 0, and you count this as a 0, right? Obviously, computers don't have little tiny LEDs in them necessarily for this sake. It's just electricity, but for the sake of the example, we're going to use LEDs, right? So either they're on, 1, or they're off, 0. The value of each bit, each one of these lights is called a bit. The value of each bit doubles as it grows. So the first one starting on the right starts at 1. It doubles and goes to 2. It doubles and goes to 4. It doubles and goes to 8. So these are 4 bits, right? You only have 4 binary numbers here, but the values go from 1 to 2 to 4 to 8. So notice this binary number right here is 1100. Right? On, off, off. You can tell that these two lights are on, these two lights are off. So how do we know what number this is? What we're going to do is add up the values of each bit that is on. So since 1, 1, these first two are the only ones that are on, we're going to add up this 8, and we're going to add up this 4, and we're not going to count these because they're off. So this is going to give us the binary number, or the decimal number, 12. Right? 12 in binary will be 1100. Okay, so let's look at some more examples of that. We'll take away the LEDs for a second. We'll just use these. Again, we start with 1, we go to 2, we double that, go to 4, and we go to 8. If none of them are on, we'll leave it white. That's all zeros, and that's our number 0 as well in decimal form. If we want to add 1, if we want to turn 1 on, we'll just turn on this 1 light bulb, right? So this will be off, 0, 0, 0, 1. This is the only one that's on. We'll use red as on. Okay? If we want the number 2, we're probably going to have to go over here and turn this light off. Right? So in order to get that value, we have to do 0, 0, 1, because this is on, 0. This is this number is the tricky one, right? To get to 3, there's no 3, right? It goes from 2 to 4, there's no 3. So in order to get 3, we need to put 2 and 1 together. 2 and 1 together, it would look like this, and that would be the binary number 0011. To get to 4, we'll turn those 2 off and turn on the 4. To get to 5, we'll have to do kind of like what we did with 3 and add this 1 over here. That would be 0101. And just take a second to think about what the 6 might be, right? We're going to have to turn off the 1. We can leave the 4 on, and we'll turn on the 2. So 6 is going to be 0110. This would be 7. This would be 8, 9, 10, 11, 12, 13, 14, and 15. Notice that for 15, we have turned on every light we have, right? We've turned on the 1, the 2, the 4, and the 8. If you add all that together, you get 15. But what if you want the number 16 or 100? Or 200. Well, you're going to have to add more bits or quote-unquote light bulbs, LEDs, like we've been looking at, right? You're going to have to add more bits is what it's really called. Okay, so the example we've been working with is only 4 bits long. So a bit is a single 0 or 1. So we had 4 capable zeros or 1s. And we're going to go ahead and add some more bits to give us some more possible numbers. This is just a random fact, by the way. 8 bits, 8 of these, equal a byte. Right? 8 bits equal a byte. So just like we did with the 4 bits, it's going to go up. It's going to double each time, the powers of 2. It's going to go from 1 to 2, from 2 to 4, right? Double. From 4 to 8, that's what we were using before, all the way up to 8. Now we're going to add a new one, so that's 16. Double of 8 is 16, 32, 64, and 128. Okay, so let's look at some examples like that, right? We have all these dots now, and I won't go through every single one, but if we want to turn on some lights to equal 36, we could turn on this 32 and this 4, and that will give us the binary number 001, 001, 00. The binary number 01010010 would be 82. That means I turned on the 64, I turned on the 16, and I turned on the 2. And let's say I'm taking a test, right? How can we commit this to memory? So if the question says, what is 17 in binary? I would start drawing out your little light bulbs, right? Double it each time, the powers of 2. Start at 1 on the right, do 2, 4, 8, 16. And circle them if it helps you remember this visual, right? To get 17, we need to turn on 16 and 1. So the 16 would be on, that's 1. And the 1 would be on, that's 1. And everything else is going to be a 0, right? So our number 17 in binary is going to be 10001. So when you have those kind of test questions, you want to just go ahead and write that out on paper. Thanks for watching this video. In the comments below, I want you to try to convert the following numbers to binary: 18, 50, and 134. I recommend doing this on paper before you go down to look at the comments in case other people have answered already. Hopefully this helps you out, and talk to you later.